Now, if this denominator equals this denominator, I can say that this numerator equals this numerator. So once you have fraction equals fraction, you can set the numerators equal. So we get 20x minus 4 equals 12x plus 33. Then I said to you, if you have an x on one side and an x on the other, and you spend more than 3 seconds figuring out which one you should move, you've wasted parts of your life that you're not getting back. So I have 1x and 1x on both sides. Pick one and move it. So I'm going to pick this one. So that should be your next step always when you have two x's. So I get 8x minus 4 equals 37. Some of you move the number first. That's okay. Add 4. 8x equals 37. Divide by 8. X equals 37 over 8. And then x can't equal negative 11 over 4. You always have to follow behind with your non-permissible values, because if your answer was a non-permissible value, it would be extraneous. It will happen sometimes. Okay. Number 2, I have a denominator of x, a denominator of 3, a denominator of 1. They're all monomials. So monomials you can make be monomials, right? So this one I'm going to multiply by 3. This one I'm going to multiply by x. This one I'm going to multiply by 3x. So I get 9 over 3x plus 5x over 3x equals 30x over 3x. And then I get 9 plus 5x over 3x equals 30x over 3x. Please be quiet. Now if this denominator equals this denominator, after this step I can say, okay, then this numerator must equal this numerator. And I get 9 plus 5x equals 30x. Subtract 5x. 9 equals 25x. And I divide by 25. I'm recording. X equals 9 over 25. And I have to follow behind with x can't equal 0, which is fine because it doesn't match it, and we're golden. I'm giving you 2 more. Then we're going to do some set theory ones, and then we're going to move on to set theory. Finishing it up. So this is number 3. 4 over x plus 6x over x plus 1 equals 6. Now, paying attention. This is an x, this is an x plus 1. This is a monomial, this is a binomial. Can I make them be the same? No, so I have to multiply them by each other. And the 6 is over a 1. So I actually have to multiply it by both the x and the x plus 1. And then 4 is 2x over x plus 3 plus x over x minus 3 equals 18 over x squared minus 9. What do I spot here? The difference of squares, which actually makes this easier. This is going to be an x plus 3, x minus 3. It's already going to have a common denominator. So I'm just going to have to multiply the first one by x minus 3 and the second one by x plus 3. Actually makes it easier. So try out 3 and 4. This one here is a monomial and a binomial, so I have to multiply this one by x plus 1 and this one by x plus 1. This one by x, this one by x, and then this one by both, x and x plus 1. So, this one I'm going to get 4x plus 4 over x, x plus 1. Plus 6x squared over x, x plus 1 equals, now this goes into the end bracket and stops, so I get 6x times x plus 1. So I just end up with an extra step. I'm going to put this side together because they have the same common denominator. So I'm going to get 4x plus 4 plus 6x squared over x, x plus 1. Now this one looks like it's an actual harder question because it has an x squared and people freak out. Sometimes they're really nice to you and they'll give you ones where your x squareds cross off and then you don't even have to deal with an x squared. Would you stop abusing the ladybug or something? I don't know what's happening. Okay.
No.
It's just a really awkward part on this thing, but that's okay. And then we have 6x squared plus 6x over x, x plus 1 Now that the denominator is actually equal, we get 4, and we can write the numerators equal. So 4x plus 4 plus 6x squared equals 6x squared plus 6x. What happens when I have a 6x on both sides, or 6x squared on both sides? You can subtract it off, right? You subtract it off, they actually just cancel, so I'm left with a nice linear one. 4x plus 4 equals 6x. Subtract my 4x over. 4 equals 2x, divide by 2, x equals 2. Then I have to follow behind with x can't equal 0 or negative 1, does it? No, so it's good. Now we're going to deal with the other one that is not as nice. You end up having to use quadratic formula. First off, you have to spot that it's x plus 3, x minus 3, which most people did. So we get 2x over x plus 3, and I have to times this one by x minus 3. Then I have x over x minus 3, and I have to times that one by x plus 3. And then this one is 18 over x plus 3, x minus 3. So it already has a common denominator. Distribute these, so I get 2x squared minus 6x over x plus 3, x minus 3, plus x squared plus 3x over x plus 3, x minus 3, equals 18 over x plus 3, x minus 3. Now we have a common denominator, so we can put them all over it. So we're going to get 2x squared minus 6x plus x squared plus 3x over x plus 3x minus 3 equals 18 over x plus 3x minus 3. Then my denominators actually equal each other. When my denominators equal each other, I can set my numerators equal. Because if this equals this, then my numerator, which is 2x squared minus 6x plus x squared plus 3x equals 18, must equal. Collect like terms, I get 3x squared minus 3x. When I have a squared and it doesn't go away, what must I do? Move everything to one side, set equal to 0, and plug it into the quadratic formula. Because the only way you can plug it into the quadratic formula is if it's all to one side. Because that's what it says on the quadratic formula sheet. Now I have my A, my B, my C. X equals negative a negative 3, so 3 plus or minus the square root of negative 3 squared minus 4 times A, which is 3, times C, which is negative 18, all over 2 and A, which is 3. So I get x equals 3 plus or minus, this becomes 225 over 6. The square root of 225 is actually 15. And then this splits. So I get x equals 3 plus 15 over 6, which is actually 3. It's 18 over 6. And x equals 3 minus 15 over 6, which is negative 12 over 6, which is negative 2. So my answers, this is the catch, my answers are x equals 3 and x equals negative 2, but x can't equal plus or minus 3. Ruh-roh. This one equals 3, doesn't it? So I have to circle it, put a line through it, and say extraneous. Because even though it's there, it's not actually an answer because my NPB kicks it out. And then this is my only actual answer. So you have to watch. If your answer is one of the non-permissible values, you have to circle it, cross it out, and say extraneous. Yeah? Okay, can you guys sit down and just open up some loose sleep? We're going to do some notes and some review with set theory and move on. We're going to keep going, so we're going to do set theory continued. So say I give you the universal set. It's the set of whole numbers. Actually, I'm going to say set of natural numbers. Sorry. less than or equal to 18. What I want you to do first is list the universal set. Universal set is the set of. List the numbers. Natural numbers means what? Starting at 1. Less than or equal to 18 includes 18. So we do 1, 2, 3, 4, 5. Do not put dots in here. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So that's my universal set. Then I have to give you some sort of subsets of this, correct? Some sort of subsets. So I'm going to say P represents the prime numbers. Do I have to say less than or equal to natural numbers less than or equal to 18? No, because I just gave you the universal set. Those are the only options you have, right? So P represents the prime numbers. E represents the even numbers. L represents the odd numbers. Greater than 2. Greater than 2. I want you to list what's in each of those sets. All the numbers. So P would equal, the first one you guys said was 2. It was the only even. 1's not a prime number. Then 3, then 5, 7, 11, 13, 17. Now E represents the even numbers. So 2, 4, 6, 8, 10, 12, 14, 16, 18. L represents the odd numbers greater than 2. So what am I going to start at? 3, 5, 7, 9, 11, 13, 15, 17. Why didn't I have to give it like a greater than 2 and less than blah? Why didn't I have to give the less than part? Yeah. Right, it's in the universal set. I have to stop at 18. It's not an option, right? Okay. I want you to list any sets, P, E, or L, that are subsets of each other. So for example, I'm going to say P is a subset, which is that sideways U, of the universal set. Because everything in P is in the universal set, right? 2, 3, 5, 7, 11, 13, 17. We know that in order for something to be a subset, it can't have more elements, right, than what you're putting it into, correct? So I know the universal set has way more elements than P, so the universal set can't be a subset of P. So P can be a subset of the universal, but the universal can't be a subset of P. We agree? So I want you to list every single universal set you can, or oh my gosh, every single subset you could come up with. Okay, you list me some. P is a subset of U. What else? Anyone else? Simon, what'd you get? What's one? E? L is what? L is a subset of U. Yeah. Because everything in L is in U, right? What else? Yeah. E is a subset of U. Ooh. There's also one more. Yeah. U is a subset of itself. Actually, all of them, there's a ton more. I could go U is a subset of U. I could go E is a subset of E. I could go L is a subset of L. I could go P is a subset of P. There's still one more. You could say the empty set's a subset of all of them. What else? There's actually 2 sets that are subsets of each other. Anyone know? Could we say, trick question, could we say that L is a subset of P? No, why? There's a 15 and a 9 in L, and that's not in P. Could I say P is a subset of L? P has what? A 2. So there aren't any subsets that way. The only extra one we could say is like the empty set is a subset of P, E, L. So L and P actually aren't subsets of each other because each one of them has a little too much. The other one doesn't have, right? Okay. Those make sense? Okay, today we're going to talk about intersection and union. We'll deal with intersection first. So intersection. We're going to use the above sets as well to deal with this. So intersection, on your formula sheet, it shows it as a downwards U, like this. So sideways U meant subset, correct? If we forgot, it's on a formula sheet. It says subset. This one means intersection. Now, intersection and union are opposites of each other in a certain way. Intersection and union, one of them is and one of them is or. Okay? Between intersection and union. I'm going to show you how I can tell. So if I can take the symbol and I can write the word and with it, it means and. Oh, I can. So this one means and. And I'll explain more what they mean after. Union is the other symbol, which is a proper U. And if I go to try and write and with it, it looks really stupid. Does that actually write the word and? People say kind of. No, it kind of doesn't. So it's not and, it's actually the other one. It's or. So intersection means and union means or. Okay? Intersection is a symbol that's downwards, and if I try and write the word and, I can. So I know it's and. The other one I can't write and with it, so it's or. Yeah? Yeah, that's why I don't use the O thing to make it or. If it can't write and, it means or. If it can write and, it means and. The only options we have are and or. This symbol here, the downward symbol means and, the upward symbol means or. I just used writing the word and with it. It doesn't mean that it actually spells the word and. Okay? If you can actually write the word and with it, it means and. And you're like, well, that's silly. You're going to be doing it, so trust me. You'll use that tactic. Okay? Now, let's think about it. This class is a set of students. We agreed yesterday? Okay. I want everyone to stand up who has blue eyes. Okay? I want everyone to stand up who has socks on. Randomly picked that. Okay. I want everyone to stay standing who has blue eyes and socks on. You stay standing if you have blue eyes and socks on. So who stayed standing? Yeah. Yeah, people who have blue eyes and socks. So and means you have to have, you're like, no doubt, Lepp, that's stupid. Yeah, I know, but you guys are going to screw these up. So and means it has to have what? It has to have what, if it means and? Both. It has to have both, correct? Okay, let's do it again. Stand up if you have blue eyes, stand up if you have socks. I'm going to show you a difference. Stand up if you have blue eyes, stand up if you have socks on. So if you have just socks or you have blue eyes, you're standing up. So if you had socks on your feet or you have blue eyes, you're standing up, correct? Or is more, is there not? If I say or, there's more of you, is there not? Because you're standing up if you have blue eyes, you're standing up if you have socks, you're standing up if you have blue eyes and socks. So or means what? Either or, you pick it, correct? Did and have less of you when I said and? Yes, because you needed to be in both. We agree? But if I say or, if you have one or the other, you get listed. If you have both, you still get listed, don't you? Right? Okay, sit down. We're going to do this with numbers, and it's going to go debauchery, but you completely get it with humans. So, what if I say this? What if I say, so here's my sets. Okay? What if I say P intersection, so this is my little example, P intersection L. What does the little intersection mean? And, because I can write the word and with it, correct? And what did and mean when we did blue eyes and socks? The people in both stood, correct? So I'm going to list the numbers in both, just like I did with people standing. So what if the number's in one or the other? Do I list it? No, it has to be in both in order to be intersection, in order to be and. Do we agree? Okay, what numbers are prime and L? What numbers are P and L? Is 2? No. Is 3? Yep, so I list 3. Okay, what about 5? Is it in both? Yep, so I list it. What about 7? Yep. What about 9? Nope. Okay, what about 11? Yeah. What about 13? Yeah. What about 15? No. That's it. It's literally the trickery. That's all it is. It's not even trickery. It's just and means it has to be in both. Just like socks and blue eyes. You only stayed standing if you had both. Correct? Now, what if I did union instead? So I did P union L. Well, I would take the union, I would try and write the word and. Nah, it's stupid, so this means or. What did or mean when I said the whole class was or? If you had either or both, you were listed. Even if you had both, you were still listed, right? This is where people get mixed up with the or. Yeah?
Why did you put 17?
Is 17 one of them? Yeah, it's just because I don't have the list in front of my face. You do, because they're on paper, on a scroll. So thank you. 17 is in both. So P or L. When it's or, if it's in P or it's in L, I list it. If it's in both, do I just list it twice? No, I still can just list it once. So if it's in P or it's in L, it gets listed. What numbers are in P or L? 2. What else? 3. What else? 5 is in one of them. What about, it's actually both. 7. What else? 9, because 9 is in actually L, but it's not in P, but I still list it, because if it's in either or, I list it, correct? What else? 11, 13, 15, 17. So I list the double ups and I list the singles. If it's in one or the other, I list it, correct? Just like if you had socks on or blue eyes, you stood up. If you had both, you still were standing, right? Because you stood up for blue eyes or socks, correct? So or is often more. Or often lists more. Look at the and. I listed way less than the or. Why is that? Why does the and have so many more, less listed? Because the and you have to be in both. And the or you can be in either or and get listed, correct? When's the only time your and and your or will result in the same answers? When's the time your and your or will result in the same answers? Anyone know? And means, sorry? And means both, correct? And or means either or. When is the chance you're going to get both of them to be the exact same with and ors? If the sets have to be exactly the same. That's the only way. Because then you'll get all of them in and you'll still get all of them in or because you had them all in and, right? It gets listed. So and means has to be in both, or means either or 99.9% results in more, right? Because the only time it's not going to result in more is if they were the exact same set. That's the only time. Okay, you're going to practice a couple. Example, I want L intersection E, and I want L union E. It can be written like this as well. And if you're like, I don't remember what symbol it is, remember you have a formula sheet, and it goes union and it gives you the U, right? So you can go to your formula sheet. So if I see L union E, the very first thing I'm going to write is L union E to help me out. Okay? You guys write what numbers are in those sets. Go. So this means intersection, and how do I know if it's and or or? I try and draw the word and. It worked. So it's and. So what's in L and E? What would I put? 0 with a slash because it means empty set. If I go to L and E, nothing in common, right? Okay, what about L union E? U, when I go to write it, that doesn't make and, so it means or. What's in L or E? Lots of stuff, right? Everything that's in both, you just list it all, which is a whole bunch of things. So it's going to be 2, 3, 4, is it everything but 1? 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Right? Make sense? Okay. So, we're going to do this is another example. The universal set this time are the natural numbers less than 20. Excessive L usage. So the first thing you're going to do is list the universal set and all the numbers in it, right? Then A equals divisible by 3. B is divisible by 5. And C are multiples of 6. So you write them all out, please. I will scroll that back. Once you do that, you're going to go A and B, list them. A union B, list them. And then we're going to try them and see if you can do this. A complement intersection B. So before I do 3, what am I going to have to list? The complements of A, right? So try these ones out. So, universal set, natural numbers start at 1 and go to 19 because it says less than. Okay, which ones are divisible by 3? 3, 6, 9, 12, 15, 18. Which are divisible by 5? 5, 10, 15. What about multiples of 6? 6, 12, 18. Okay, A, this would make and B. So what's in A and in B? 15. That's it, right? This one isn't and, because if I go to write and, it doesn't make sense. So it's or. What's in A or B? Anything that's in either or. And it's in both, if it's in both, sorry, I still list it. Or people mess up, they don't list the ones that are in both. You still list it because it's in either or. It just happens to be in both as well. Win-win. Now, not A. I'm going to list what's not in A to help myself out. 1, 2, not 3, 4, 5, not 6, 7, 8, 9, 10, 11, 13, 14, 16, 17, and 19. So I want what's in A, not A, and, intersection, and in B. What's in not A and in B? 5 and 10. How do you do with that? Good? So, here are some ones that are a little trickier. What if I give you D is 2, 4, 6, 8, 10, 12, 14, 16, and 18. And I want A and B or D. What do I always have to do first? Even in order of operations, what do I have to do first? It's called bed mass for a reason. What do I have to do first? Yes, brackets. So I have to do the brackets first. So off to the side, I'm going to have to do bud. Beauty. Is that or and? It's not and, because it doesn't write the word and, so it's or. What's in B or in D? B is 5, 10, and 15. It's right up here. And D is 2, 4, 6, 8, 10, 12, 14, 16, 18. What's in B or in D? List anything in either one, right? So 2, 4. Or often means more. So if you're writing lots, that should make you feel better because 4 means more. So we have 2 and 4 are in D. Then 5 is in B. Then 6 and 8 are in D. Then 10 is in both. So I still list it. Then 12 and 14 are in D. Then 15 is in B. Then 16 and 18 are in D. And then above it, I'm going to list what's in A, just so I can't see it. A has 3, what was it? 3, yeah. 15, 18, right? And I list them on top of each other because I want what's in A. What's the symbol? And B or D. So how do I do it? I find B or D first, write A on top of it. Now I want the elements that are in A and B or D. So what's in A and B or D? 2 isn't in both, 3 isn't in both, 4 isn't in both, 5 isn't in both, 6 is. 8 isn't, 9 isn't, 10 isn't, 11, or 10 isn't, 11 isn't in either. 12 isn't in both. 14 isn't, 15 is in both. 16 isn't, 18 is in both. You see how I split it up? How you do the B or D first, write them on top of each other and list what's in both, right? If it was or, I would list every single one of those numbers, wouldn't I? That's the only difference between and or. And you list what's in both, or you list anything that's in either or. Okay? Now I have your textbook for a second. But one last thing to explain. So disjoint is the last thing. It's called disjoint. Disjoint sets, you're going to want to write this down, have nothing in common. So for example, if A and B were disjoint, which they are, if we look up here, A and B, do they have anything? Oh, A and B do. Which ones are disjoint? B and C are disjoint, right? Do B and C have anything in common? B is 5, 10, 15. C is 6, 12, 18, correct? So if I went above and I went B and C, what would it result in? What would B and C result in? An empty set. That's how you know they're disjoint. If you can do the intersection of two sets and you get the empty set, it's disjoint. So if you can take the intersection of two sets and they result in the empty set, two sets are said to be disjoint. So how do you prove disjoint? You take the intersection and you get the empty set, right? But in this case, B and C are disjoint. Sometimes they'll just ask, what are the disjoint sets? And you'd say B and C, and you'd be done. They ask to verify, you'd have to say B and C equals the empty set. Okay? So you have two questions. Page 32, number 3, page 15, number 12. Don't draw a Venn diagram. We haven't done that yet. You just do what we just did, okay? And those two will be asked for on Friday morning, so make sure you're doing them.